So let's start with the question. It's time to duel. Something you may not know about Morph is that he's a big fan of the Yu-Gi-Oh card game. So there's a card game. He loves to duel with anyone he meets. To gather all fans who love to play as well, he decided to organize a big Yu-Gi-Oh tournament and invited N players. So the game has N players. Morph arranged the N players in a line numbered from 1 to N. They then held N-1 consecutive duels. For each I from 1 to N-1, the player I faced I plus 1, producing one winner and one loser per match. Afterward, each player reports a value AI. Okay, so in this question, we have N players. All these N players fight with each other in a duel. So N-1, 0 to N-1 would be the indexing. So each player fights with its consecutive player. So 0 would fight with the player 1, 1 would fight with the player 2, 2 would fight with the player 3, and so on. After fighting, they will record each number 0 or 1. Okay, so 0 indicates they won no duels and 1 indicating they won at least one duel. So the entries in the array would be 0 or it would be either 1. 0 indicates that the player 0, for suppose in this example, has not won any duel, and here the player has won a duel. We don't know it's only one duel or it's many duels. For example, if here we have 0, then we can surely say that this player fought with this player and he or she didn't win. Okay, so 1 indicates that the player has won at least one time, or it can be many times also. So let's move forward with the question. Since some may lie about their results, example reporting a 1 instead of a 0 or vice versa to influence prize outcomes, Morph will cancel the tournament if he can prove at any report to be false. So this states that the report can be false or not. So we have to tell if the players have reported a lie or not. So how are we going to proceed with this problem? Let's see the first test case. It's N here. The first line indicates the N, which is the number of players, and the next is the array A. So in the first test case, we have 3 players reporting their win or lose, 1 and 0. 0th player, first player, and the third player. So how to know if someone was lying or not? Let's see at the player 1. The player 0. Player 0 will be fighting with the player 1. By seeing both of the entries, first as 0 and as 1, it is clear that the player first has won the game. Okay, so we can conclude that. So that is okay. That can happen. That can be the scenario. The player 1 will fight with player 2, and obviously we can also see that player 2 has not won any matches. So it's player 1 who has won both the matches. So we can conclude that, and this situation can be possible where only one player wins both of the times. So here we can conclude that there is no lying. So then we will output no. Let's see the second test case. Second test case is two players and both are saying they lost the game. How can it be the case that both have lost? The player 0 and player 1. The player 0 is going to fight with player 1, and there's someone who has to win, right? So we'll output yes. Let's take one more test case to see what the pattern here is. Let's see the next test case. It says that both of the players have won the game. Okay, 0 and 1. So the player 0 fights with player 1, and it says here that player 0 has also won and player 1 has also won. So that can't be possible. So this test case we will output yes, because there is cheating in that. Let's see the next test case now, fourth. It has 4 players, 2, 3 and 4. Zero, 1, 1, 1. 0th player, first player, second player and third player. So the 0th player will fight with the first player will fight with the second player, and here we can see that the player 1 has won. It is possible. Here we can see that player 2 has won. So 1 here does not indicate that the times when the player has won. It indicates that at least the player has won one or many times. So it can also be the case that the player 2 has won here. Okay, so it can also win one time, it can also win one time. When the player 2 and 3 fight, it can also win one time. Okay, so what are we seeing here while solving all these test cases is that we can conclude here that when we have consecutive zeros, whenever we have consecutive zeros, it cannot happen that we have consecutive zeros, because if one player loses, the other one wins. So it must be that one is a winner and one is a loser. Okay, so we cannot have consecutive zeros. So first observation we have is no consecutive zeros we can have. Let's see the other another observation. From here we can see that there cannot be two consecutive ones one one. There cannot be two consecutive ones if there is not at least 1 0. For example, let's see here, we have to have at least 1 0 in order to make this test case to a no. How? If it is 0 and it is 1, then we can conclude that one player has lost and one player has won. If we have here all ones when the players are 4, we can see that there is no one who has lost. Okay, so it cannot happen. But if we see that here is a 0 and here is a 1 and then here is a 1 and then here is a 1, okay, so this player will fight with this player and we can conclude that player 1 wins, right? And when this player and this player fight, we can conclude that either one of the player is won. Let's take it 2, it has won, and when they both fight, this player won. So we can have consecutive ones only if and only if we have 1-0. Okay, so what is the second condition? It is we can have consecutive ones if and only if we have at least 1-0, at least least 1-0. Okay, so these are the only thing that we have to take care of. There cannot be any consecutive zeros, and there can be consecutive ones if and only if there is at least 1-0. Let's see the other test cases, if our theory works or not, if our observation works or not. Okay, when we see this test case here, 1 0 0 1. Okay, so this is player 0, this is player 1, this is player 2, and this is player 3. You can see that this player fights with this player, and okay, let's see player 0 1. This player fights with this player, but nobody won, so that cannot happen, and we will return false, as there is lying in this case. Let's see the next test case. Here we have 7 players, 0 1 0 1 0 1 and 0. Okay, so here we have player 0 fights with player 1 and player wins. Player 1 fights with player 2, and it can happen that player 1 wins, because 1 shows that the player has won at least one time. Okay, so it can be 1 and it can be 2 times also. Let's see for player 3. When player 2 and 3 fight, player 3 wins. When 3 and 4 fight, player 4 doesn't win, player 3 wins. So player 5 and player 4, when they fight, player 5 wins. Player 5 and player 6, when they fight, player 5 only wins. So this test case is also where we can say that there is no lying amongst the players. So let's see the code for this problem. Okay, so t is the number of test cases. While t minus minus, we enter the integer n, which are the number of players. We enter the elements of the array A. Then I have made a function solve that takes in the vector A. N is equals to a dot size. I have made a 0 bool which checks that there is at least 1 0 present or not. Okay, then we check the n minus 1th player to be 0 or 1. Okay, and why do we check it here? Because we are going to run the loop from 0 till n minus 2. Okay, because it's less than n minus 1. So what will happen is it will compare the players I and I plus 1. It is not going to go up till n minus 1th player, because it is going to check n minus 2nd player with n minus 2 plus 1th player, which is n minus 1. And as soon as I is n minus 1, the loop is going to break out. So this condition won't be checked. This condition for the n minus 1th player won't be checked. So we're checking it in the first. Okay. Okay, so here the condition is checking if a of I and a of I plus 1 are same or not, and if they are same, if it is 0 or not. This is for checking the consecutive zeros part. Okay, as soon as it finds there are consecutive zeros, it returns false. When it breaks out of the loop, there are no consecutive zeros, so it checks if there is at least one zero or not and returns that. So that's it. I hope you like the solution, and if there are any improvements you can tell me. Thank you.